Alright, so we're back to me sort of floundering around trying to fix this. Um, but I am going to get it. So I've copied that sketch from a previous one, so that gives me that sort of inner edge there. So now I'm going to hide this, pull up that. What I now need is the outer edge, which we have from another previous sketch as well, which is there. So we now have, that's the shape, right? So let's see if we can get this to work. So we're going to extrude cut that shape. We're going to do it as an offset from surface. We want to translate the surface, which should give us the whole thing, by 1 millimeter. Reverse offset. Maybe. Maybe. Maybe we need a different surface. So the issue might be because each one of these is a different surface, and it doesn't want to do sort of what I'm asking it to do. We're seeing the translate there, right? So it's working sort of that one, but not the rest of them. This is a tricky one, isn't it? It's because of the curves. It's always because of the curves, and I don't want to show you guys the easy way, but I'm going to. So the way you do this is using surfaces. So I know you can't see this feature, insert surface. We're going to go to offset. So I've got a set of parameters here. What I'm going to do is just click all these surfaces. So it's going to create a surface with no thickness, basically. Offset 1 millimeter. So surface modeling is a whole nother type of modeling. I really don't want you guys to have to worry about it or deal with it, but it is another approach to kind of modeling. But what doing a surface in this case allows us to do, this is one of these doing things the right way, I guess, is it allows us to use the surface that we created. Actually, we don't even have to do offset to surface. We should do up to body, surface body. We'll see if this does it. Maybe running into something slightly weird. So it's saying that the body does not fully terminate the extension. That's most likely because it's like edge on edge. So we'll have to do a surface. There's a thing called extend for surfaces. So if we hide that solid body, you can see that we have this surface body here. I can select an edge. And we're going to do like 2 millimeters, but make sure we get the whole edge. If we click that little arrow guy, it propagates along tangencies. So we want to make sure that we click the whole edge and all its little odd things. Definitely getting into a little more complicated modeling here. You do not need to go to this extent at all. If I'd planned this out, I probably would have approached it slightly differently. But I dug this hole, and so I'm going to climb out of it. probably going to tell you how to skip this part if you really don't want to watch it. Alright, so there we go. Let's see if this does the trick for us. Whoops. So, extrude cut. That shape up to surface. That one. Haha. The body we're cutting is this one. Haha. Hide the surface. There we go. So now, if viewed from the side, you can see that we have this edge, this lip, so it would rest on there nicely, so that when this thing does get fit in, it fits in nice and flush. These two pieces would actually be one piece in this case. So we'd have this whole upper bucket and then this lower pan. It gives us a real clean look. So, yes, so now we're here. So the next thing I'm going to talk about are ribs and screws, mainly because a lot of times you don't want to friction fit, you need something a little more rugged, and so having things screw together is a slightly better idea. Best thing to do, and really for this sort of flat bottom method, screws are really, really great ways of fixing it. But what I'm going to do in this case, for the moment, is sort of wind ourselves back so that we just have the standard sort of 2-half unit, and then I'll talk about screws. So let's see. Where did we do something silly? There we go. That's the bottom split. So, all right. So now we're back to just 2 halves. Yay, everything looks good. So now what we're going to do is add sort of some ways of getting screws in here. This is a pretty open housing, so we have to do sort of a little bit of strangeness to get our screws to actually meet up with each other properly. One of the first things when dealing with screws is that you would actually pick out your hardware. Screws come in all sorts of standard sizes. We're going to talk about this in class. I don't have the exact date, but we are going to talk about hardware and how to select and all of that jazz. But the basic gist of it is when doing screws in 3D printed parts, generally you're going to use some sort of insert for the threads. In this case, we'd be using what's called a mold-in insert. And I'm just going to demonstrate how to put basically one screw here and one screw here. But really, I'm just going to do one and then mirror it. Nothing too terribly complicated. The thing to start with is we're actually going to start with sort of on the top. We're actually going to go, let me draw this out a little bit, or at least talk about it. So we've got this half. Since this is so long, we're actually going to have the meeting point of the two housings sort of more down here. So the screw will come up through the bottom and actually start screwing in like here. So in order to do that, I'm going to make a quick plane to draw on. That'll be sort of this screw meetup plane. It's going to be off that top piece by 5. Nope, way more than 5, like 10. Yeah, we'll do 12. There we go. Alright, so let's sketch on this. And we're going to hide the bottom. Whoop. Cool. Alright, so the first thing we're going to do is what's called these. It's basically what we're making are a series of bosses. It's just sort of the term for these. Really, really simple. In this case, it's just going to be sort of a extruded tube. So we give it some size. We give it a location. There we go. And we're going to do extrude back. Up to body, we're going to up to this one. And we're actually going to do a draft on this guy. Not much. 3 degrees. We definitely don't need this kind of sort of intense structural stuff that I'm going to throw in because this is such a small part, but it's sort of good to be aware of. The next thing you would do on this is you'd cut a hole for the molded insert to go in. I have no idea what molded inserts I'd be using for this. Or I have a general set of sizes, but I don't know what size they're going to be. Right now I'm just going to put 5 millimeters, and we'll say it goes in 8 or 6. Like it, we don't really know. We'll talk about this more in detail when we actually talk about hardware. I'll probably pull this model out and we'll set it up correctly. One of the key things to do with these is to add a reasonable, not necessarily super huge, but a fillet around the edge. Just helps make a slightly better bond there. Will help that part from fraying off. We can also add some ribs in that sort of come off, sort of triangular support ribs. I'm not really going to for this one. I may do some ribs on the bottom though. So we've got that. So that's 1/2 of this equation. The other half gets a little more complicated. Nothing terrible, so just has to meet up with this. So what I'm going to do is actually hide this. I'm going to sketch on this guy. Probably going to use a similar size. Doesn't hurt. Now we need to hide this one, show that one. And we'll do extrude. So we're going to extrude this down, up to body, other way. But one of the weird things I'm going to do, or just different things, is I'm going to offset this by 0.1. So as you can see, I'm actually slightly down from the sketch. I'll explain why in a moment. So if we do a section cut of this, and we look at these two parts, by not having them touch here, when this housing comes together, these two won't be actually in contact with each other. So it won't bulge weirdly. So now the thing to do is basically to make a hole for the screw that would go in here. Pretty straightforward. We're just going to sketch on there. Whatever diameter that screw would be, say it's 3, say it's an M3 screw, 3 millimeter. Although if it were an M3, we'd even want to give it just a little bit more space around it. We're going to go through all. And then we're going to come in on this bottom side. We're going to add another hole. Make it 5. No idea. And we're going to extrude cut this in 2 millimeters. So this would be for the head of the screw, so that when it goes in, it sits nice and flush with the bottom. So last thing to do is to throw the fillet around the edge. There we go. So now we've got 2 screw bosses. So now this housing screws together rather than just being a friction fit. Cool, right? So now we'll do a mirror, and we'll mirror this stack sort of features. There we go. Whoops. Whew. Doesn't like something. It may not appreciate the, let's see, may not appreciate something like one of those up to surface kind of deals. Or I just didn't quite click something correctly. Let's see. Whoops. Definitely not liking it. Things happen. What we'll actually do is I think I'll do them separately. So there's the top, and then, whoops, it's a plane. Man, there's something about this feature. Really, something about that feature. Well, we'll just throw it in by hand then, right? Good practice. So we'll do it again. We didn't do any draft on that one. Let's throw that back in. Draft outward 3 degrees. There we go. Alright. So we're going to do the offset of 0.1. We're going to draft outward of 3 degrees. We're going to go up to body. Whoops. Draft has to be outward. There we go. We could actually because it's based off the mirror. That's what's gonna. Whoops. All right. Sketch on this surface. Our screw diameter. Once again, I'm making these numbers up off the top of my head, so when you're actually using screws, you'd measure them, or you'd look at the dimension drawings. Usually, if you're getting them off McMaster, they're dimensioned already. Is that 5, right? There we go. So we've got our 2 screw holes, which are excellent. If we wanted to do a rib, we would just do sort of an extrusion along the inside. I think we're okay for now. So let's do some buttons. We're going to do 2 types of buttons. We're going to do a flexing button and a hole button. Then we're going to do a switch, and we're going to talk then a bit about LEDs and how we can control them. So let's do the flexi button first. I like flexi buttons. So we're going to end up sketching on the top, but what really matters here, whoops, is where everything is on the board. So we're going to hide our top. So in this case, I'm going to sort of have this index around this button. In reality, it doesn't have to. It really could be sort of a whole variety of shapes. But the easiest way I have found to make sort of these flexi buttons so this is a button that is part of your housing. Your housing is going to flex and press it rather than it being a separate piece. Or that's the idea. So now we're just going to do a offset, very small, probably like 0.2 millimeters. But the key with this is that you have to check it when you go to print to make sure that it's actually going to be clear and not going to get filled. We could do 0.5 to be safe in this case. We are going to run into some issues with some LED stuff, but it'll be okay. You would sort of design around it because you would have planned how your LEDs are going to behave, etc. So basically what we're doing is we're cutting a channel. I am going to come in and make sure that the back end of my channel is rounded. This distance needs to be long enough, but not super long. Depends on how far away the actual button contact is. But for the most part, it actually doesn't have to be that terribly long. So we've got this channel. We're going to do extrude cut through all, but just make sure we're just doing the top. There we go. So now we've got this channel. So we're going to hide the bottom. So now we just need a contact, basically. Something to actually hit that button. Being that I modeled the buttons in their uncompressed position, I can actually model this thing to basically sit like right on top of it. And it'll work really well. So all I need is a pad. In this case, I'm going to make this pad reasonably large, but I don't want to obscure my LEDs. So we'll go with 8. Go. And we can extrude this up to the body. Merge the result with that. With this. There we go. Whoops. There we go. Perfect. So now this piece of plastic will flex. It will press into that button, and we've got a button really easy rather than having to do a separate part. If we wanted to do a separate part though, we could. So we want this to be concentric with that. Doesn't necessarily have to be. It can be offset as long as we are getting that contact, right? And in this case, we're just going to cut a hole. Let's go with 10. And once again, through all, but just controlling our scope. So now we've got a hole. Although I demonstrated in class with a series of extrusions, a slightly faster way, I guess, or just another way, right? to create sort of the button insert is with a revolve. So in this case, we're going to do a similar thing. Maybe we might leave a little bit of gap space so we don't have a false positive. There we go. So we've got the rim to sort of keep it in from falling out. And what we can actually do, which is kind of fun, I'll do it on both actually in just a second, is we'll throw some domes on there, some concavities and stuff, so that these buttons are a little more interesting. Main thing is that we have slight gap from the edge so that it can move properly. This definitely needs to be centered. Ooh, there's an interesting thing. So remember, our buttons are not completely centered, but that's okay. Like the actual hardware button isn't completely centered, but the one we're modeling is. It should be fine, as long as we get a good contact on it. So there we go. Just need a midpoint. Whoops, not that midpoint, but there we go. For construction, and some sort of height above the surface here, maybe 2. Cool. So now we can just do a revolve. There we go. So now we've got 2 buttons, which are excellent. What we can do as well, so I'm going to create a plane just a bit above this surface. That'll work. I'm going to use it to split the surface. Ooh, something looks wrong there, doesn't it? There we go. I think something happened with where that hole is, and yeah, where my button lies. So I believe, let's see, what happened? I think the hole for the button is directly over, maybe. Yeah, I think the hole for the button is directly over the button, but the button cap is not. So there should be a relationship here that I'm missing. That one. I'm just going to throw in a dimension. Just like that. There we go. That's better. We're going to do curves, split line, this guy onto this surface and that surface. So we now have those surfaces split. We can come in with a insert features dome. In this case, we're going to dome this one in. I think we'll do both in. I don't know if it'll let me do. There it goes. Ooh, but that one looks weird. Let's do that, and then we'll do another one. Dome, 1 millimeter. Other way. There. So now we've got some concavities. So both of these are buttons, both pressable. Now I'll do the switch, and then we'll do some LEDs. So the switch gets a little more complicated. Not much, but a little. Let's hide this top piece. There we go. So the key with the switch is making sure that it wraps around and then bumps it. I actually would need to pull out my board here and model, make sure I get the size of the single switch. Although I have the full travel, I don't have the switchy bit itself. But it is sort of straightforward. Easy way to start is to just model sort of on top here of the switch and get the two initial pegs. So we know that one is going to go right sort of on this edge. Whoops. And the other one would be somewhere over here. And we might give a little bit of room. Not quite sure what that dimension is. And we want maybe it to be mid-pointed on there. Easy way of doing that is diagonal. Whoops. Having some weird midpoint to midpoint issues. Or I'm just getting tired of looking at all this for a moment. This will work. Sometimes you just do things that you know will work. So if these two lines are equal, right? I know that. I'm the midpoint. Yay. There we go. Alright. There we go. We'll make these guys 1 for now. Alright. Make extrude these up. We're going to offset them slightly so they aren't rubbing. There we go. And 2 millimeters seems great. Nothing to really merge them with yet. Alright. So that's the start. Now we need a good section view so we can sort of see what's going on. So this is going to bump this switch, but now we need to sort of get the switch out to the outside. So what I'm actually going to do is model the whole switch itself and then create the clearing area for it. So my next step is going to be sort of to go up from here. So we're going to model on top of this. Pretty straightforward. Just going to do a little, oops, it's a little square. Throw some dimensions on it. Make it collinear with these guys. And make it just a bit wider than our switch. Cool. Alright. Now we're going to extrude this up, and we're actually going to extrude it up. Basically, just offset slightly from the bottom. By like 0.2. Maybe 0.1. We're going to merge the result, but with these two. Alright. So, making progress. So now we're going to add the top of our switch. So we really want to be on the top surface there. Sketch. We're going to make it sort of lozenge shaped. There we go. Alright, and that midpoint. So, if you're doing this, you really should be planning out sort of these dimensions instead of just winging it. But I'm winging it. So, oops. So we need this to protrude through. By 2. Maybe by 1. We want to merge it, but just with this. There we go. Now with our little switch, I'm going to sketch on the side, give it some texture. so that's a bit more grippable. Actually, easier way of doing this, just to draw one of these. And we'll pattern it. So I'm doing this sort of skyboxy thing, just so that it'll cut out that section. Make those equal. It's horizontal. Make it quite ridgy. Do a linear pattern that direction. That looks pretty good. So now it's sort of the hard part, if you can call it a hard part, of the switch. It's just knowing how much throw the switch has. You would probably want to measure this as well, but we can make a sort of a reasonable guesstimate by using the measure tool. That edge there is 2.8 millimeters. So from this edge, maybe till there or so is where that face of that button is going to go. So maybe 2 millimeters or so. So we can just sketch. We know that our switch is at one end of sort of the side here. I'm actually going to make this nice and relative. And so say it's a 2 millimeter throw. We've got our throw distance here. So throw some more verticals on here. So we're going to have a tangent there, an offset, and an offset. There we go. So say that's that's that same 0.3. Now this can get tangent there. This one can become tangent there. Excellent. So that can go through all, but just for, that body. There. So now our switch can switch back and forth. You may want to make that bottom plate, in this case, we can make that bottom plate a bit wider so that when it does switch, we don't see the switch through it. So maybe we make that 4. Hopefully that doesn't break anything. Yep, perfect. So now we don't see through when our switch moves. Cool. So there's our switch. So finally, last thing I'm going to do is talk a little bit about LEDs and LED sort of housing control manipulation kind of thing. So we're going to sketch on this top face here, but then we're going to hide the body. So say we wanted to do something with like this set of LEDs where we wanted them to be like really clear and visible, and sort of create maybe like a bar kind of thing. So what we're going to do is first we're going to sort of thin out the material so that the light shows through easier. And we're just going to do it for this set of 4 here. Actually, do it slightly different. Whoops. Some relationships in place there. Maybe a perpendicular or something. Just going to do parallel and then a distance of like 1. Although, it's that moment where I realize there's a better thing to do. So, by having it nice and centered, or the shape nice and centered, it'll look better when it's all said and done. We might still be able to use that and say 10 degrees. Reference. There we go. So, step 1. We want to make sure that we select just there. It's going to be reducing that thickness. Now we do know it's 2 millimeters. And so we could just say, 1, but we'll do an offset. So now this area will light up brighter, right, than the surrounding area because it's thinner. And now what we can do to further sort of amplify this effect is to do another sort of sketch on that surface. We're just going to show our sketch from the previous ones that we know where it is. I think we're going to run into a slight issue with one of those holes, but it's okay. But we're just going to offset by 2 millimeters that way, and offset 2 millimeters that way, and same goes for that one. Same goes for that one. And we'll just sort of close this up here. And then convert these guys that should do it. Did I miss something? Yeah, thought I did. There we go. So now this will let us make some walls. The trick with making these walls, though, whoops, wrong part, is that we don't ruin everything else. So we actually need to make sure that we leave space for both the button and its hole, so we can just offset that guy by, say, I don't know, 0.5. There we go. And make sure that we don't impact any other components. We may have a problem there with the switch. It's sort of difficult to tell at this point. Actually, I have a feeling that we'd end up impinging upon that switch. So what we can do, so one of the hazards of using sort of a tight board like this is that everything's real compact and it's a little difficult to deal with some of these contingencies, but we're going to try. So we'll just adjust the shape of our wall again. So we know that this guy is going to travel that edge right there. It's going to travel about 2 millimeters that way. So we can take a look at that again. So we know that that's coming 2 millimeters. And we'll maybe want to give a little bit of buffer on the side, like a 0.3, sure, why not? There we go. Easy enough. So now we can extrude this. And the goal with this is to get sort of down around those LEDs as best we can. It may be that we can't because components get in the way or things of that nature, which is fine. So we'll do it like 3 millimeters. Merge, just make sure we're merging with this. There we go. So now if we do a quick section view, looking through this, we can see that we now have this nice sort of area that the LEDs are going to shine into. So we've now made a housing. We have ways of attaching it together. We had 2 different ways of sort of splitting that housing. We have support for the board. We have some different buttons. We have switches. We've got LEDs. So hopefully this will be enough to get you guys sort of started and up and running on 5B, I guess this is, which will be modeling your own housing. You have any questions, please let me know. Good luck with it. Sorry for the sort of the rambling bit at the middle of this video, but sometimes you run into problems. Cool. So that's modeling housings around circuit boards with some different buttons and things.